Most builders hit a wall silently. As their Claude workspace grows, every session slows down. You keep adding instructions, but without a clear architecture, the system becomes heavy, grinding forward instead of working at speed. This line shows a severe 25% drop-off in efficiency. Because your root configuration files load at the start of every single interaction, any bloat in those files acts as a 25% token tax. You are paying the AI to reread hundreds of lines of irrelevant text before it ever looks at your actual prompt. We are going to build 3 precise fixes to reclaim that overhead: a self-sorting automation engine, a zero-cost memory archive, and a lean routing nap. Upgrading this infrastructure moves your workspace from a passive chat window into an active processing engine, where your prompts reach the AI without being buried under layers of structural debris. To fix the files, we need to be able to read them. Claude's instructions and memory live in Markdown format. Reading and editing raw text files is slow and risks accidental formatting errors. We use a free app called Obsidian to open the workspace folder. Instantly, dense blocks of code resolve into a clean layout with bold headings and a readable sidebar. You do not need to learn Obsidian's advanced features or change your software habits. It acts strictly as a clean lens to view and adjust your Markdown code safely. Step 2 is aggressive removal. If you have rules detailing how to create a specific weekly newsletter or a unique file type, those are situational. They do not belong in the root document because you do not need them for every single prompt. Ask the AI to relocate those non-essential rules into a separate reference file. Watch how this dense block of situational text collapses down into a single glowing pointer link. Now the root file simply reads, "Check this link before creating a new file." The system only loads that specialized text on demand. This pointer-based architecture directly eliminates the token overhead that was being wasted on context you weren't using. Even with a lean root file, output quality will degrade if the system is confused about what to remember. The most frequent cause of AI hallucination is a workspace that mixes permanent behavioral rules with temporary facts. We use 2 tests to separate them. Test 1. If an instruction uses prescriptive words like always or never, it dictates behavior. That makes it a permanent rule, and it stays in your root CLAUDE.md document. Test 2. If a statement describes a current status, like your current software stack or an ongoing project, it will inevitably change. That makes it a temporary fact. You can instruct the AI to audit your entire workspace right now. Ask it to flag any entry whose primary purpose is recording a status and move it to memory. This logic filter visualizes the split. Rigid, permanent rules route to the left, while fluid, temporary facts route to the right into your active memory file. The entries sort themselves into cleanly organized, distinct columns without you having to read every line. Active memory works best when it is focused on what is happening right now. At the 150-line mark, the file becomes dense enough to begin confusing the AI's priorities. We set this as a hard ceiling to force a choice. What is still relevant today, and what has become historical data? When you breach that 150-line ceiling, the fix is archiving. Think of your active memory as a highly visible, dynamic whiteboard for today's projects. Once a project concludes, its data moves to an archive file, which acts as a closed, heavy filing cabinet. Claude does not read the archive file automatically at the start of a session. It only opens the filing cabinet when you explicitly ask about past events. Physically relocating historical data permanently secures your long-term memory without triggering any recurring token costs. Now that the static file architecture is lean, we turn to the active workflows. Every day, random downloads, receipts, and PDFs create noise in your digital inbox. Instead of sorting these manually, we deploy a scheduled background task. At the start of every session, the AI automatically processes your inbox folder, funneling scattered receipt and PDF icons into precise subfolders. We apply a strict categorization logic to this automation called the P.A.R. method, standing for projects, areas, and resources. This forces the system to sort your files based on immediate actionability, not just by what file type they happen to be. With inputs sorted, we optimize your outputs. When you want the AI to do work for you, you must distinguish between your 2 primary task environments, Workstations and Skills. A workstation is an ongoing area of focus with its own voice and accumulated context, like drafting a weekly newsletter. It inherently requires you, the human, to provide judgment and make decisions at each step. A skill, by contrast, is a closed loop. This flowchart illustrates the decision matrix. From the single node, we ask, is this a place I work or a thing I do? If it is an ongoing place I work, it branches to a workstation. If it is a thing I do, an automated, repeatable checklist designed to execute a narrow process identically every time, it branches to a skill. Isolating repeatable actions into strictly defined skills prevents context contamination from your larger workstations. You know exactly what the system is checking, guaranteeing mathematically predictable outputs. Your workspace is now structured for speed. You have an ultra-lean root configuration under 300 lines, a strictly disciplined 150-line memory ceiling, and self-executing daily automations handling your inbox. The impact is measurable. You go from a heavy, slow-loading setup into a system characterized by rapid, synchronized rotation. Session load times drop because the AI is no longer struggling to find your instructions, and you secure a permanent 25% reduction in token costs. There is only one bottleneck left: your old, isolated Claude projects. They contain valuable instructions and knowledge, but they sit entirely outside of this active, interconnected system. Dismantle those static legacy projects, copy their instructions, and paste them as new workstations in your live setup. By migrating them, you ensure that every future prompt, correction, and edit compounds the overall intelligence